Hello everybody, thank you for joining me in this video session. In this video session, I will show you how to build a multicast traffic environment in the VM Maestro application, as well as show an example of a packet capture. So let's begin. The first thing I want to do is go ahead and open up the VM Maestro application. Once the application has been opened, go ahead and open up the Layer 3 Multicast VIRL file. Now that the file has been opened up, let's launch the simulation. To launch the simulation, click on the icon up here that indicates to launch the simulation. Now the simulation will take about a full minute to fully launch, and we will have to wait until the devices transition from a absent state to a building state to an active state. And this will be indicated by the icon turning over here into a green color. And then the absent will be indicated as active. Okay, so now that all the devices have transitioned to the active state, we can go ahead and start building the multicast environment. So the first thing that we want to do is open up the terminal windows for all the devices. I'm going to do an example on the first one, and then we can do the same thing for the remainder. So the first one, I'm going to right click to open up the menu, select Telnet, and then click onto its console port. And this will automatically open up the window to the right of the application on the bottom right corner here. Now it's a little hard to see here, so what you want to do is click and hold on the tab and drag it to the window here next to the console tab, so that way we can get a better view of the terminal window. Now we can click, hold, and select all of the other devices and do the same thing. Right click, highlight Telnet, and click to all 6 nodes console ports. And now we automatically have all the terminal windows open up in the bottom of the screen here. Now a neat trick that we can use, and if you click the terminal multiplexer icon over here, it will open up a terminal multiplexer tab window on the bottom right here, and we can now select all the devices and run a command simultaneously among all the devices instead of having to do it individually one by one. So in order to do that, just go ahead and click check mark all the devices, and now we can run a command simultaneously on all the devices. So the first thing we want to do to build the Multicast Lab is initialize the CLI. So hit enter in the command. Okay, now we have the CLI initialized. We want to enable it so that way we can start configuring the device. And in order to run configuration commands, enter the terminal by issuing the command configure terminal. Okay, now that we are in the terminal level, we can start running commands, and the first command that we're going to run is IP multicast routing. This will initialize the multicast routing amongst all the devices. The next thing that we want to do is enable IP PIM sparse mode on all the interfaces. So since all devices have at least one interface, we can run this in the multiplexer. So in order to do that, we need to enter the interface level. So run the command interface GI, which is short for gigabit Ethernet, and then the interface number, which is 0, 1. Okay, now we're in the interface gigabit Ethernet 0, 1, so go ahead and run the command ippim sparse mode. Now gigabit Ethernet 1 is enabled for ippim sparse mode on all the devices. So now we can run the command on the rest of the interfaces, but keep in mind on which interfaces you have enabled PIM sparse mode and which need additional configurations. Okay, now that we have enabled IP-PIM sparse mode on all the given interfaces, there is also an additional interface that we want to configure. So switch over to the Rendezvous point tab, and it's not indicated in the topology here, but we need to configure interface loopback 0 as IP-PIM sparse mode. And the loopback interface has an IP address that we will be using as the rendezvous point address so that all the devices will be able to know where and how to reach the rendezvous point by the loopback address. So let's enter the loopback 0 interface and enable IP-PIM sparse mode. Okay. Now we've enabled IP-PIM sparse mode on all the interfaces, including the loopback interface. The next thing we want to do is configure the rendezvous point address. So in order to do that, you need to exit the interface level on all the devices by entering exit. And just go ahead and check that on all the devices if it's out of the interface level. And this can be checked by simply seeing the CLI to be in the config level. Okay, looks like we're all on the same level. The next thing we want to do, since we're going to be implementing IP-PIM RP address, the rendezvous point address on all the devices, we can go ahead and run the command simultaneously. So in the terminal multiplexer, go ahead and select all the devices and then run the command IP-PIM RP address, and we're going to use the loopback address, which is 192.168.0.6. Press enter. Okay, now we have initialized the rendezvous point address as the rendezvous point's interface loopback address to be used as the rendezvous point address. Now that we have configured the multicast environment, let's go ahead and enable a traffic capture on one of the interfaces. So in order to do that, minimize the application and open up a Chrome browser. Once you open up a Chrome browser, enter the IP address of the VIRL server. In my case, it's 192.168.1.3. Once we're in the VIRL server, open up the user workspace management to get into the user workspace management homepage. Go ahead and log in. Once we get to the homepage for the user workspace management, scroll down into the area where it says simulations and click on the name of the simulation currently running. Once we're in the simulation homepage, scroll down until you see the interfaces section. Here is where we can select the option to capture traffic. The interface that we want to use to capture traffic will be receiver monitor gigabit Ethernet 01. So go ahead and find the node receiver monitor and the interface name gigabit Ethernet 01. And all the way to the right is this icon that looks like an eye, which is the create traffic capture option. So go ahead and click on that. This will open up a few options that we can select while we create a capture, but we can just go ahead and click create. So once this has been enabled, we can go ahead and do a couple of verifications to see if it was implemented correctly. The first one is under the traffic capture section, where it will say that the running state is true for that node and for that interface. Okay, now we can minimize the browser and open up the VM Maestro application again, and also make a second verification by this icon that is indicating there is a traffic capture on this interface. Okay, now that we have traffic capture on that interface, let's generate some multicast traffic. In order to generate the multicast traffic, go ahead and find the receiver monitor tab and enter the command on the interface level, the IP IGMP join group command. So the first thing we want to do is enter the interface for that node, which is going to be interface GI01, and then we want to join the group to generate the multicast traffic. So the command will be IP IGMP join group, and in this case we'll use the multicast address 224.10.10.10. Okay. Now that this node has indicated that it wants to join a multicast group, let's go to the video server source and just run a simple ping command to generate a simple multicast message. So ping to the multicast address 224.10.10.10 and press enter. Okay, now that we generated a quick traffic for the multicast address, we can go ahead and open up the traffic capture file to notice what kind of messages were exchanged. So in order to see the traffic capture, go ahead and minimize the VM Maestro application once again and open up the Chrome browser. Now, in the location where we indicated the traffic capture, go ahead and open up the traffic capture by clicking on the icon that looks like an eye, and it will be indicated as fetch captured data. And this will automatically open up or download a file which can be opened up automatically in a Wireshark application. It is a PCAP file, so the Wireshark application is used as the default application. So here we see the traffic that was generated on that interface. And what I want to do now is filter out the messages that was generated on the multicast address as being IP.dst equal 224.10.10.10, and then go ahead and click the blue arrow indicated to the right here. So here we can now see that a IGMP message was generated on that interface. So we can click on this packet and see that an IGMP version 2 message was generated to the multicast address 224.10.10.10. This is a IGMP membership report indicating that that device on that interface is wishing to join the multicast address 224.10.10.10. Okay, so now that we've shown an example of a traffic capture, we can now close the Chrome browser and end the simulation. So in order to end the simulation, go ahead and return to the VM Maestro application, and in the window pane where it's indicated as simulations, right-click on the name of the simulation and go ahead and select Stop Simulation. Once you click the Stop Simulation, check the box that says Close Associated Terminal Views. This will automatically close all the terminal windows to the bottom of the screen here. Once we have checked that, go ahead and click OK. So now all the terminal windows have closed automatically, and the simulation is now terminating and will be shut down properly. Okay, this is a little quicker than when launching the simulation, and we'll just wait until all of the devices have terminated. Okay, now that the simulation has fully closed, go ahead and close the VIRL tab, the VIRL file tab, and close the VIA Maestro application. And that's it. So I want to thank you for joining me in this video session, and I hope you enjoyed the video.